Okay, so in the previous video I showed how to make this amazing fast procedurally generated cloud background from layered whirly noise. Generating the whirly noise in real time was slow, but I found a way to pre-calculate it and store it in a texture, making it feasible for use as a background in my game. In today's video I want to focus primarily on making the level models look slightly more interesting with the help of a rim lighting shader. Now for those of you who are not familiar with rim lighting, it's an effect that is often used in photography. You then place a light source behind the object to light up the silhouette, while the rest of the object is dark. This effect is also known from the Wii game centered around a certain Italian plumber. As always, I will go to the previous video and download the source from here. I'll download the one with the baked whirly noise. There we go, I will name it part 5. And the first thing I'm going to do is just run the project and see what it looks like. So this is where I left off in the previous video. Now the camera is panning back and forth and the clouds are drawing and the level model is not drawing. So that is just because all of this code is commented away. If I remove that and remove the camera panning, let's increase the text size. I actually remember to do that from the beginning. That's a first. Okay, let's just test and see that it works. Yes, so we can still jump from shape to shape. And I hope to make the shapes look a little more interesting today. So the first thing I notice is that the lighting is wrong for the level. So I will, right now in the sky shader, I define light direction directly. I want to send this as a uniform instead, so I will call this U light direction. I'll create a new uniform vec3 U light direction. And I will also add that to the planet shader. It should be in the vertex shader. Let's see. I'll use that there. And I also need to send that to the shaders. So I'll send it to the sky shader first, light direction. And let's set it to 0, 0, -1. Actually, I want to create a new global variable. Global.light direction is equal to 0, 0, -1. And then I will use index 0, 1, and 2. Let's see. And let's copy this for the planet shader and let's move this vector to the create event. And let's test it and see if it still works. Okay, so now the lighting direction makes a little more sense. Now the objects are lit in the direction of the sun. So the next thing I will do is go into the planet shader, and this is where I'm going to create the rim lighting. Now I have everything I need for the rim lighting here. I have the world normal, and I have the view matrix, and I have the world space position. And there are multiple ways of doing rim lighting. You can get the camera position and then get the vector from the camera to the vertex and then do the dot product between that and the world normal. I actually prefer to do it in a different way. So I will, instead of doing it like this, multiplying the matrices together, I will split it up and I will create a new vector called vec3 view space position. And just for the sake of consistency, I will remove all the spaces from this as well, or the underscores. There we go. So now we have world normal, world space position, view space position, and I want this to be a vec4. Let's see. There we go. Let's comment this out and create a new section, rim lighting. Now, I want to use the view space position, so I need to also transform the normal into view space. And the way I do this is by creating a new vec3 view space normal, and I want to transform the normal, the world normal, and this is a vec3, so I need to create a vec4, and I want to set the translation part to 0. That means that I don't want the translation of this to affect the normal. And this is a vec4, so I need to return the XYZ. So now we have a view space position and a view space normal. Now this is a 4D vector, but that doesn't really matter. The whole point here is that view space position is the position of the vertex in relation to the camera. So the camera, in view space, the camera is placed at 0, 0, 0, and is looking along the Z direction. So if we then do, let's see here, I will create a new varying called v rimlight, and let's just test something here. I'll do the dot product between the view space normal and the normalized view space position. And let's also send this to the fragment shader. And just for now, I'll remove the regular shading, and I will add this to the color. And let's see what this looks like. I'm getting an error. That's because I forgot to do this. And I also get an error here. Let's add that instead. Okay, and if you notice, the center of the object is completely black, and then it's brighter along the edge. That means that this is negative in the direction of the camera. So if we do 0.5 plus 0.5 times this and see what happens then. Okay, now the edges are lit up, but everything is lit up. So I'll do 1 plus this. And now it should be 0 in the direction pointing towards the camera, and it's 1 at the edge, and at the side pointing away from the camera it's larger than 1. But we don't care about that. So what happens if we then multiply it with itself? Okay, the edge is a bit a bit smaller, a bit thinner. How about we raise it to power? Let's raise it to power of 5. Okay, this is starting to look like something. And this is the basic idea behind rim lighting. Now it looks like the objects are all lit up from behind. Now it doesn't always make entirely much sense. Like if I'm facing this dark area, I would expect the rim lighting to be less bright than when you're facing the sun. And I can actually fix that. Because we do have the view normal, the view matrix, so let's create a new mat4 v equals that. And then I want to multiply the rim light with the dot product between the light direction and the looking direction of the view matrix. And that is stored in index 0.z. Let's see, we should make a vec3, index 1.z and index 2.z. And let's see what happens now. Okay, so when I am facing the sun, the border is darker, and facing away from the sun it's brighter. So let's do 1 minus that instead. So facing away from the sun, the effect is completely gone. Facing towards the sun, the effect is very, very bright. So I want to reduce it slightly, and I can do that by adding 0.75 and subtracting 0.25 times that. So now it goes between 0.75 minus 25, which is 0.5, and 0.75 plus 0.25, which is 1. So it should be 0.5 when facing away from the light, and 1 when facing the light source. And as always, you can play around with the values. I don't entirely like the way this cylinder looks. Also, if you can see, if you look at the player, you can see the squares of the vertex buffer, and that is because we're doing this in the vertex shader. So what you can do, if you'd like a smoother surface, is move all of this to the fragment shader, and I'm actually going to do that right now. So the whole point is that this vector should be normalized in the fragment shader instead of the vertex shader. So I will add a new varying. Actually, I'm going to name it view space position. Varying vec3 view space position. And we'll set this equals to that. And let's normalize it in the view, in the fragment shader. And I will also add a normal. Let's see. There we go. And these two I will move to the fragment shader. And let's see if it works. All right, I don't have this vector, so let's add another varying float. The rim light strength, and let's add that here as well, and let's move this. Actually, I'll do this. And I'll set this equal to that. Let's test this. Okay, now it's not working at all. There we go. Okay, that's not what I expected, but I forgot to normalize this. Let's test again. Okay, so now the artifacts on the player is gone, and there we go. That's our rim lighting shader. So that's that. Now the next thing I want to do is to change the sky background a little bit. All I'm going to do is move this from here and into its own separate object. So let's create a new object and let's name it OSky and give it a draw event. There we go. And let's also create this object instance, create depth 000 OSky. And let's move this in there as well. And what I actually want to do is to downscale the sky and then upscale it when drawing to the screen. And the reason for this is that while it is much faster than it was when I was generating the whirly noise directly in the shader, it is still doing 5 iterations plus this one, which is 6 iterations for each pixel. And it is slightly blurry anyway, so downscaling it and then upscaling when drawing to the screen is perfectly acceptable. And I don't think anyone will even notice. But what I want to do then is to not draw this directly to screen. I want to create a separate surface, and let's name this Sky Surf. And I want to copy this. So if Sky Surf does not exist, I want to create the Sky Surface. And let's set the size of the Sky Surf. And that should be the half the size of the application surface. There we go, and the height as well. And we should set the target. I'll just copy this and copy that. Sky Surf. I'll clear the texture. Let's clear it to see black. It doesn't really matter. I want to turn off Z testing. And Z writing. So now we are drawing to the Sky Surface. I need to set the camera as well. So camera, apply, view, camera 0. And when drawing to screen, I want to set a custom view and projection matrix. So matrix set, matrix view. And I'll build a look at matrix, and I want the camera to be centered at the center of the Sky Surface. So that is Sky Surf word, Sky Surf width times 0.5, Sky Surf height times 0.5, and X from I'll just set that to 1. And the same for the X and Y from the 2 direction, but I want to look at Z 0. And I want Y negative to be positive, or to be the up direction. As for the projection matrix, projection, I want to build an orthographic projection, which has the width of Sky Surf width, Sky Surf height. And since I'm only 1 pixel or 1 unit away from the plane, I want the near value to be 0.5 and the far value to be 2. And let's just try drawing the surface, Sky Surf 0, 0. And then I also need to apply the camera for the rest of the drawing. And I want to just test this and see if it works. No, it does not work because I'm using player model. Let's use the sphere model instead, and in the OSystem object I want to make all of these globally. Torus, disk, block, and cylinder. And let's try again. Okay, so nothing is drawing, and I forgot to re-enable the Z testing. I think that might actually be because I haven't reset the shader. Let's see, also I will re-enable these. True, true, and try again. And now the sky is downsampled. So it's drawn at half the resolution in each dimension, which means that we're only calculating the sky for 1/4 as many pixels as before. But it still looks as good. Actually, I want to mess around with this a little bit. Let's try increasing the number of iterations to 6 and see what that looks like. That just looks amazing. Yeah, this is perfect. What happens if I increase this a little bit as well? Okay, and when drawing I want to remove everything I don't need. So I enable no culling. I can actually enable that up here. And I don't need to do that there. And I don't need to set the world transformation. Actually, there's one more thing I can do. In the sky vertex shader. Because I don't want the camera to be able to ever move outside the sky sphere. I want the sky sphere to follow the camera everywhere. And the easiest way to do this is to simply remove the translation of the view matrix. So let's see here, I can actually clean this up quite a bit. I can use the normal. Let's create a new vec4 normal and then run. And let's put this inside there. Let's create a new matrix from that and multiply it by the normal. And then I can get rid of all of this, and I can get rid of that as well. And I'll remove this and just see if it still works. It does not work. What if I set this to 0? No, it does not work. But at that, let's see, I should multiply this by 2 because otherwise it's too close to the view. So now it works, and now the view, now the clouds are always following the camera, so they aren't really bound to a sphere anymore. And let's reduce the reduce the power of the rim light slightly. So let's set this to 4. And that's it for today. I would say this looks quite a bit better than it used to.